Hello everyone, my name is Arsalan Ghifari with the NPN of 18061878871 from Mechanical Engineering of University of Indonesia. And here I am going to talk about destructive test. What is a destructive test? Destructive testing are the tests which are carried out till the specimen's failure. Tests are carried out to the specimen's failure in order to understand a specimen's performance or material behavior under different loads. As we can see in the right side of this slide, there's a picture of a machine that names tension. This machine is used to do this destructive testing. Why we need a destructive test? The first is to know exactly at what load a specimen failed, verifies properties of a material, determines quality of welds, helps you to reduce failures, accidents, and costs, and to ensure compliance with regulations. But first, I'm going to explain about ductile material. Ductile materials are materials that can be plastically twisted with no crack. They have the tendency to halt the deformation that occurs in the plastic region. If tensile force is applied, these materials can be stretched into a wire, but if compressive force is applied, they can be deformed into sheets. Common ductile materials are copper, aluminum, and steel. And the second one, there are brittle material. A brittle material is one that will break as opposed to bending. When you apply a load, a material must twist marginally to endure the load. At low loads, materials will come back to their old shape after the load is lifted or flexible. At high loads, the distortion is perpetual or plastic. These loads are unique for various materials. Common brittle materials are glass and ionic crystals. And for this experiment, we need to use a plate specimen of iron plate, or we could say the ASTM A8 for plate. We are given the ASTM A8 for plate with the width of 13.7 mm, the thickness of 4 mm, the length of 96.4 mm, and the weight of 102 grams. First, we need to know about the stress-strain curve. In the stress-strain curve, there are some points that we really need to know. Like the first one is the yield strength. A yield strength or yield stress is the material property defined as the stress at which a material begins to deform plastically. And the second one, there is ultimate tensile strength or ultimate strength. Is the capacity of a material or structure to withstand loads tending to elongate. And there are a strain hardening or work hardening is the strengthening of a metal or polymer by plastic deformation. There is a necking in engineering or material science is a mode of tensile deformation where relatively large amounts of strain localize disproportionately in a small region of the material. And the last one, there are fracture. Fracture is when a material is break apart. And this laboratory or experiment, we need to processing some data like the breaking tensile strength. To find the BTS, we need to know the force break divided by the area, so we can get the value of 247.466 MPa. For the UTS or ultimate tensile strength, we got the 370.150 MPa. The young modulus is equal to 0.89502 GPa. The elongation percentage is 35.10% and the reduction percentage is 61.76%. And these are the graph. At the left side is the engineering stress strain curve, and in the right side is true stress strain curve. Difference between engineering and true stress strain curve. The curve assuming the cross-section area is fixed is called the engineering stress strain curve, while the curve based on the actual cross-section area is the true stress strain curve. The difference between the true and engineering stress and strains will increase with plastic deformation. At low strains, such as elastic deformation, the difference between the two is negligible. So, from this experiment, I've got some analysis. I think that the material that has been given to us is not an iron. Instead, it was titanium, because ultimate strength of a titanium is 370 MPa and the breaking tensile strength of a titanium is 225 MPa. So, because of this data, I think the material that has been given to us is a titanium. This is some documentary of our experiment.